This programming language really caught me off guard when I discovered it, because it made me question a lot of assumptions that I'd always had about programming languages. It makes a really interesting design decision that you probably haven't seen in any of the languages that you've used. The language is called Uiua, and that design decision is the extensive use of glyphs for complex operations. I'm going to dive straight in and show you some examples in the language so you can kind of get a feel for what I'm talking about. And then afterward, I'll reflect on what I think of the language and whether there's any aspects of it that we can apply to more mainstream imperative languages. This is UiuaPad. It's a browser-based kind of Uiua playground, so you can kind of get started without installing anything on your machine. So I'm going to start with an ultra simple example. I'm going to do +1, and that's going to add 1 to 1. Uiua is what's called a stack-based array language. So there's this concept of a kind of a global stack that you push things onto. And then when you invoke a function, it operates on things that are on that stack. So if I invoke this addition function by using the plus character, it's actually taking the top two things that are on the stack, adding them together, and then pushing it back on the stack. So this particular function expects there to be at least two things on the stack. If I take away that one, I'm going to get an error. If I push something onto the stack and I don't do anything with it, it's just going to print that out when I run the program. So the first thing that gets printed is the result of this add operation. And then the second thing that gets printed is this 1 that I haven't done anything with. I could put that on a separate line if I wanted to. I mentioned this was a stack-based array language. And in that context, what array means is that arrays are sort of a first-class citizen, and pretty much all the functions operate on arrays. So the plus operator also operates on arrays, and it will do an element-wise addition of two arrays. So if I do 1, 2, 3, and then 4, 5, 6, it's going to output an array 5, 7, 9. The other thing to note is that you can represent arrays using square brackets like you do in most languages, but they are not comma delimited, they are space delimited. So that's one thing to note. Another way of representing arrays that comes in handy sometimes as a shorthand, especially when you're nesting arrays, is instead of using square brackets, you can actually put underscores between all of the elements. So this is the exact same thing as putting the square brackets around the 4, 5, and 6. Instead of having the square brackets, I put underscores between the elements, and that represents an array as well. This comes in handy for two-dimensional arrays, so you can enclose the entire thing in square brackets, and each row will use the underscore notation to represent that row. So 1, 2, 3, 4, 5, 6. So now I have my two-dimensional array with 2 rows and 3 columns. You can see there's quite a few glyphs up here. So there's a lot of complex operations that can be represented in one character. One of them is the range function. So there's two options for entering glyphs. I can actually type range and then a number. And what this range function does is it creates an array of all the numbers from 0 to the number that you specify, non-inclusive on the upper bound. So if I do run on this range 20, it's going to automatically convert that range word into the corresponding glyph, which is kind of nice. And again, it's going to output an array with all the numbers from 0 to 19. There's also a reduce function that's represented by the slash glyph. So I can specify a function that I want to apply to each element of this array to combine it all into one element. And I can just say plus. If I run this, I should get a sum of all the elements of the array added together. Cool. So that's a somewhat complex operation represented by literally 5 characters. This is obviously kind of a contrived algorithm, but you can see in scenarios where you have to do a lot of complex operations on arrays, this can make your algorithm really concise. The other cool thing about this interface is that it will actually interpret your results as a bitmap image if it's of a certain number of dimensions and shape. So if I want to generate a simple image of a gradient from black to white, you can write the algorithm for generating that really concisely using Uiua. So I'm going to start by putting 500 on the stack, duplicating that. So now we have 2 500s on the stack. I'm going to get a range of all the numbers from 0 to 500, non-inclusive on the upper bound. I'm going to switch those. So at this point, I have 500 on the top of the stack, and then that array that was generated from the range operator, second on the stack. I'm going to swap those, and then I'm going to do a divide. So each element in the array is going to be divided by 500. So I should wind up with an array from 0 to almost 1. And then I'm going to reshape this and basically duplicate this one array into 500 rows of a two-dimensional array. I click run, And there we go. I get a gradient. So it's black on the left side because the values are close to 0, white on the right side because the values are close to 1. Actually, this Uiua logo that you see here is generated using a Uiua written algorithm. So yeah, you can see there's a cool colorful gradient in this example, and then the Uiua logo is generated using this kind of crazy algorithm. All right, obviously I've barely scratched the surface of the language. You can see there's a ton more glyphs here to check out. I do encourage you to check out the language. It's pretty fun to play around with. But let's consider glyphs for a minute. The stack-based aspect of this language is probably not going to get mainstream adoption. It's useful in certain scenarios, makes things more concise, but it might not be a good paradigm for general purpose programming languages. But let's talk about glyphs for a second. There's really nothing about glyphs and array languages that are mutually dependent on each other. You can conceivably use glyphs in an imperative language, and you can conceivably have an array language that doesn't use glyphs. Uiua uses glyphs, but it's definitely not the first language to make extensive use of glyphs. We had APL back in 1966 that was pretty similar in terms of its extensive use of glyphs, and there are many array languages that followed, the more recent favorite being BQN. It seems like all array languages use glyphs, even though they don't need to, and all imperative languages and functional languages for that matter don't really make extensive use of glyphs. There is some kind of minimal glyph usage in mainstream languages. For example, dash angle bracket is used in a lot of languages to represent various things. And you can consider double colon or double pipe operator. You can consider those to be glyphs. But there's really not extensive use of glyphs. You really don't see the toString function being represented by a glyph, or map or reduce or filter, things like that. Why is this? And I couldn't really think of a good reason. It is a bold design decision that needs to be considered carefully, but there's really nothing specific about array languages that makes it a better decision in that context. And there's nothing about imperative languages that makes it a worse decision. In both cases, you're kind of imposing this upfront cost on the developer where they have to go and learn all the glyphs, but in exchange for that, the code becomes more concise. And that trade-off is the same whether it's an imperative language or an array language. So the ubiquity of glyphs in array languages seems more to do with kind of a convention or a precedent of always using glyphs in array languages, as opposed to that trade-off making more sense for array languages specifically. All this got me thinking, what would it look like if we decided to use glyphs in a more mainstream language like Rust? This concept applies to any mainstream language. I just happen to choose Rust as an example. We have this simple function. It creates a vector of strings, hello world, and then some numbers, and we want to concatenate all the strings that don't have the number 1 in them. Pretty simple. So we do result equals vector into iter, and we do a filter to filter out the string that has the 1 character in it. And then we do a map to map it from a string slice to a string, and then reduce to concatenate everything together, and then finally unwrap because we get an optional at the end. The details don't matter. What would it look like if we replaced fn, let, vec, into iter, filter, map, reduce, and unwrap, and print line, all with glyphs? We're leaning into this a little more than maybe we need to. You could definitely argue that fn doesn't need to be replaced with a glyph because it's only 2 characters, but we're going to go with it. Here's what it might look like. A lot of folks are going to have a visceral reaction to this, but suspend your disbelief for a minute. We replaced the fn keyword with an infinity glyph. That's a completely arbitrary decision. It looks kind of cool. And we replace let with this kind of diagonal arrow. We replace the vec macro with a double arrow. These are all completely arbitrary, fast choices. These are not kind of well thought out choices. It's just kind of to get a sense of what this might look like. And then into iter gets replaced with kind of this upside down T here. This is a filter. It's kind of an intersection symbol or an intersection glyph. And then the exclamation operator is still not, that stays the same. It's implicit that this is a closure that we have to the right of filter. This is implicitly a closure that we're putting to the right of filter. So we're doing not, and then the single parameter that gets passed into that closure is assigned the lowercase alpha symbol. And then we're doing contains, which is represented by a box glyph, and then we're passing in 1, just like we were before. For map, we're replacing that with a kind of squiggly arrow glyph. And then again, for a closure that takes 1 parameter, we're representing that parameter with the lowercase alpha symbol. And then tilde is toString. Finally, we're doing reduce. Reduce is kind of represented by this downward arrow. And then the format macro is replaced by this like forte. I think in music it's called a forte. F, and then we're passing in alpha and beta. For closures that take 2 parameters, we're representing the second parameter with a beta and the first parameter with an alpha. And then unwrap is this upward arrow. And then at the end, print line is represented by this kind of hamburger menu thing. This is this feels kind of silly, but to decide whether this is a good idea, you really have to put yourself in the shoes of someone who is intimately familiar with these glyphs, knows what they mean right away, right when they look at them. They're second nature. If you don't do that, everybody's going to think that this is awful and atrocious. And maybe it is, but I think it's worth considering. Is that trade-off worth it? If we assume a situation where these glyphs are second nature to us, they're ultra readable, I don't know, it's hard to argue that this is better and more readable. Obviously, like I said earlier, there's this potentially large upfront costs in learning the glyphs, but it seems like there's some threshold in number of glyphs that is optimal. It's easy to argue that no glyphs would be bad. You wouldn't want to replace, I think a lot of people would agree that the kind of arrow glyph and the double pipe and the double colon, those are all kind of handy for representing things in mainstream languages. But what if you dial up the number of glyphs a little bit? Maybe instead of a handful of glyphs, you have 50 glyphs, maybe 100. It's also hard to argue that a language that only uses glyphs would be readable, because every time you pull in a new library, you might have to learn a new set of glyphs, and that's not sustainable. But what is that threshold? And maybe the threshold is different for every person. I don't know. Is there a way you can kind of slowly transition to glyphs as you get familiar with them? Maybe you start out with all these functions represented by kind of the spelled out words, and then as you learn the glyphs, you slowly, in your IDE or whatever you use, you slowly replace those words visually with the glyphs. I don't know. Food for thought. Let me know what you think. Should we be using glyphs in mainstream languages? I'm pretty confident the vast majority of you will say no. Maybe I'll be surprised. I don't know. Let me know what you think of Uiua. Definitely check it out if you haven't already. Thanks for watching, and we'll see you in the next one.